All right, thanks everybody for joining. This is going to be a talk that I'm actually really interested in because it hits on some of my past interests on network monitoring. Really pleased to welcome Otto Wittner from Sikt, and I hope I got all of those pronunciations right, which is the
Yeah,
Norwegian
perfect.
Agency for Shared Services in Education and Research, the Norwegian NREN. And he's going to be talking about Microdep, and it does have some relation to some of the other monitoring projects that some of you may be familiar with. So I will turn it over to Otto, and he will walk us through it.
Thank you, Jason. And I'm very pleased to be invited to present for you during your lunch hour, I believe. Or is it after lunch, perhaps? Yes, I represent Sikt, which is the new name for the Norwegian NREN. We have been called Uninet for 25 years, but now we have a new name suddenly. All right, we have a project which has been going on for quite a few years, a decade more or less, which we call Microdep. And this is a monitoring project, as Jason pointed out. And I'll present this for you and the tool which we've developed in this project. So an outline here of what's coming up today. I'll try and motivate the whole thing a little bit in the start here, and probably not that necessary in this case, but anyway, we will probably agree quickly that end-to-end monitoring has a value in our contexts. And then I'll go on to describe this Microdep system components and functionality, and describe especially what type of analysis we do on our datasets, the events we extract from the datasets, and then also say a few words about how it relates to perfSONAR. And then finally, some description of how you can contribute to this project, and hopefully we'll be able to have a demo at the end showing you a little bit what the system can offer. And please ask questions as I present during the presentation or at the end, whatever you feel is most suitable. I'm fine with both. You could probably also write stuff in the chat, but then I think, Jason, you might have to help me to give me a hint if there's a question I should answer.
Yep, absolutely.
Thanks. All right, the relevance of end-to-end monitoring. Well, we believe that the continuous end-to-end measurements have a significance because most of the operators out there, we tend to monitor on per device basis. I mean, we collect a lot of information, telemetry data, SNMP, via SNMP or telemetry protocols per device, and we study these data, we visualize and we analyze, and then when we see that everything is okay with each device, we believe that the end-to-end connectivity is up and flowing. But we not normally actually measure the end-to-end. So we have a kind of an end-to-end blindness. So we believe that actually doing these continuous end-to-end measurements can enable us NOCs to better understand what kind of experience we deliver to or how the customers experience the network service we deliver to them. Not only intra-domain, but also the interdomain quality of service, or the interdomain quality of experience to some extent. And also that we have a earlier problem awareness of the situation end to end, so that we know earlier and hopefully before the customer starts calling us what's going on, what the customer experiences. And we can also, by such measurements, evaluate and improve routing and forwarding, and that's kind of the core objective of the Microdep project. And perhaps also discover and faster debug inter-domain issues, especially, so cross-border problems. And for the customer's sake, giving them access to such end-to-end monitoring data, they might be also able to monitor quality of service towards critical applications, which they care more about, and perhaps also differentiate easier between external and internal network issues I've put there. Well, routing configurations requires care. I suspect you agree with me there. There's a lot of complexity in today's routing configurations. Our beloved protocols, ISIS, OSPF, and BGP, they all have a myriad of config options which need to be set properly. And there's a lot of security to take into the account here, and you want things to be reliable, they're multi-homing, etc., etc. And a growing number of peering partners is also typical. So all this needs care, and it needs careful maintenance over time. So we believe that the verification of successful reconfigs is very important and required via device, using device monitoring, of course, but also relying on end-to-end monitoring to see from a more customer perspective if routing configs have routing config changes has been successful. Here are some results. I'll show them first here from the projects. Some selection of end-to-end observations, which has resulted in some improvements. At some point, we discovered a 2-minute outage in the Norwegian net, which was periodic. It kept happening regularly. This 2 minutes is a little bit too much, I would say, of a downtime, and it turned out that an MPLS transport in US required some optimization in their configurations. Then also we have seen routing stopping for half an hour in the GIANT, the European Backbone Network, and also turned out to be some upgrade failure of a router down there. And then also we have had a 2-minute BGP failover time in our internal national network between the customer there, or several customers, and it turned out to be a suboptimal configuration in BGP and IS, ISIS, which gave a very slow routing failover to the secondary connection. And also we have changed the routines in Uninet or Sikt today when it comes to planned maintenance. So we are now deflecting routes in a more consistent way before we do planned maintenance to avoid downtime or packet drops. So we saw that took place by looking at the end-to-end observations. And also we have a more fine-grained understanding of loads and queues in the route or in the connections across the network, and I guess this was more important before we had the telemetry data incoming from the routers. Now we see also queues and more fine-grained information via those measurements or monitoring channels. And also we have some funny die-hard packets we've observed with the system. We have a 2-week-old packet traveling in the European network. So it's been for holiday for 2 weeks before it arrived at the destination. Also we have similar couple of hour-old packets in the Norwegian network. Interesting, probably packets stuck in some output buffer or something of a router which has been offline for a while. Some more recent findings. We have started to look into to what extent route changes causes these downtimes, and we have actually seen here in May this year that there was several occasions where clearly some route changes in Norwegian and GIANT caused downtime. So 30 minutes there in May 22nd, unless we have the 16-minute downtime also in between a connection between Copenhagen and Madrid, and also we had some shorter downtimes than down on the list here. And finally, we had some periodic case in NorduNet, the NorduNet backbone, so the North European backbone, with an 6 to 8 second downtimes when these route changes took place. So I would say downtimes here, which you not really want to see happening, and these are notable for the customers. Okay, so Microdep, that's our project, which we have had running for well, a decade now. It started off with a sort of basic end-to-end monitoring experimentation, and it has turned into a tool set or a tool suite today. But the main objective has always been to attempt to improve routing in the Sikt NREN or unit, our network, but also for NRENs in general, and especially also the global internet. So we do end-to-end measurements not only in our national network, but also on a global scale. And we of course want to reveal dependability issues at the fine-grained level by using such end-to-end measurements. And that's sort of the reason for the title of the project, Microdep. Okay, some more details about the system. It's really what you think it is. It's not very complicated set of components. We have a set of nodes out there, just VMs and a mix of VMs and hardware nodes, running constant bitrate traffic generators and sinks, sending 24/7, 100 packets per second probe traffic. And along next to this probe traffic, we run trace routes, 60 per hour, so 1 per minute, and also we are listening on the interfaces for returning ICMP responses from the network in case there are some routers talking back with the network unreachable messages, for instance. So this we have a local set of nodes in Norway, 51 nodes around the country, and some 200 flows, connections between these 50 nodes, and we also have 24-ish nodes more globally spread, with more than 200 flows also there between those. And we have even added eight nodes inside the major data centers around the world, Amazon, Azure, and Google, both in Europe and in US. So we can sort of, and we have end-to-end connections going there from selected sites in Europe, and we can then, get an impression of what our customers experience towards those data centers. We do real-time event analysis in this system, which means that whenever this probe traffic is received at the receiving end, we start immediately to analyze the traffic on that receiving node. And we note down packet losses, gaps, and do a little bit of analysis ahead and the tail of this before and after these gaps when we discover them. I get back to that actually. And we also extract queuing and jitter information, and then we study the trace route data too, looking for route failures and route changes. And also we try to correlate these route changes and failures with the loss, which gave us these results I just mentioned in May. We have also started looking into we attempted to use machine learning for anomaly detection using these data sets, and well, we're still testing in it. We seem to get very far with just using what can I call, not machine learning, but human learning and coding event detection algorithms ourselves. perfSONAR integration is in the process, definitely. We are currently in close communication with the GIANT about, and we're essentially about to join the perfSONAR development team, and we will try to move or merge this system into the perfSONAR suite as during the coming years. Any questions so far? No? Okay.
None so far.
Good. So what's actually different from perfSONAR, since I mentioned perfSONAR, we believe is this analysis part. And this is really what we think is quite unique and quite useful with this system. We actually do real-time analysis, and we select or pick out the interesting events instead of doing what's typical when you do monitoring or collect monitoring data. You usually just visualize with some plotting tool, and you see some diagrams and curves, and then with your eyes you need to sort of see where these interesting events are. We try to actually find those events and count them. All right, here is more details of the perfSONAR integration we are working on. So you might recognize these architecture diagrams. So we have perfSONAR here at the top, 5.0 architecture, I will say. And well, the Microdep architecture has quite similar components. With the measurements tools and some collection tools, of course, and some database storage set of components, as well as some visualization and tools at the top there. And we foresee that we could merge these by utilizing some plugins in the P-schedule in perfSONAR and perhaps this RabbitQ message server to feed these measurements from this PostStream tool, the WAMP tools, into these analytic components, which again output the events back to the database somehow. So this is a rough sketch, so I'm not sure if this is how it will end up. So I just recently sent that sketch to the perfSONAR guys, so so far haven't received feedback. Okay.
So we did have a question come in. If you would like to pause for a minute.
Yep.
Jorge wants to know, how are you measuring the fine-grained queues formed at the routers and switches? Are you using APIs provided by the vendors, or did you write your own code? And then there's a second part, which I'll ask after you answer that one.
All right, okay. No, we don't access the routers at all. So this is just end-to-end measurements, just the probe traffic flowing from end to end. And what we do to get an impression of the queuing taking place through at one of the routers or several of the routers in such a connection is that we essentially calculate or detect the minimum delay we see over time, a time window of some minutes at least. And then if we see variations of the minimum delay, if it increases significantly, sort of a spike, we consider that as a queuing event, especially if there's no loss. We just see a sort of a sudden rise in end-to-end delay, and then it drops again back to the same level. We call that a queuing event. So that's the way we detect. Okay.
Okay. Yeah, and I think you answered the second part of that as well. No, I think you answered the second part too. So we should be good. Jorge, let me know if you have follow-ups.
Right. All right. So here we have the user interface, the map you will see if you visit the microdep-uninet.no webpage. This is an open webpage, so you can visit it whenever you have time to fiddle around with it. We present all the connections in a connectivity map. It looks a little bit like veggie spaghettis, vegetarian spaghetti. But well, these connections, these lines, of course, do not at all show which path the connections flow along. They're just indications of ends being interconnected. And we have some coloring codes on the lines to indicate to what extent there might be an issue or there might be some events of interest for that connection. We have Well, I'll get back to the details here when I do a demo, but I can just mention a little bit more here. We have a set of different stuff we measure, which I've already mentioned, gaps, queues, and then these route changes and errors, both TCP or based on TCP route and normal trace route. Right, and then whenever you click on the link, you get some more detailed statistics. And you also get a list of the events which we've seen during that day. So I mean, this usually you display one day at a time in this interface. All right. More of that page later during the demo. We also have some other visualization options in this front end. First of all, we have a trace route viewer. This is fairly useful. Using some graph tool, we managed to draw what the path looks like. And we also have a sort of a summarized, daily summarized table of trace route, which you probably recognize, similar to what perfSONAR offers. We have some diagrams just showing queue development. This, I guess, is this what I just explained, the difference between the minimum delay measured during a time period and the actual delay seen at the points in time. We also have a heat map variant of the map there you saw with the collection spaghetti. This might be easier to use if you want to see if this is a particular node in trouble, for instance, and we see it here in this example that we have the Trondheim measurement point is definitely struggling a little bit here now. So there's probably something wrong with the measurement point rather than something out there in the network. Okay, so to the different events. How much time do I have, by the way, Jason?
It's a full hour, so we're
Full
about
hour.
halfway through.
I never spent that much. Okay.
Yeah, you're about halfway through.
All right. Excellent. Right. So these gaps, as I already explained a little bit, we categorize them in two different sizes: big ones and small ones. And the small ones, or the big ones, are larger than 50 millisecond gaps. So essentially 5 packets lost. And this is just taken from this old ITU standard of 50 millisecond downtimes, or being kind of a limit to what you can live with a real-time or real-time connection. Also voice over something connection. We do a little bit of analysis of head and tail of these gaps. So the 50 packets before such a gap are analyzed. Some statistics on those, sort of if they try to detect if there's a queuing increase or if there's some other effects there. Also, the tail is analyzed similarly. And the smaller gaps between less than 50 milliseconds, they are not registered as dedicated events in the database. They're just summarized, and we have a sort of a daily summary of the number of those. And as mentioned, we have a 2000 packet, maybe it's more now, I can't remember, a window which we sort of drag along when we do the analysis, so that and we analyze all the packets there to find the minimum delay. And this is sort of our reference point with respect to the next event type here, the queues. So we have, as probably several of you know, that there's one challenge with doing end-to-end monitoring if you are interested in delays, and that's keeping the clocks synchronized. And we struggled with that for many years. Playing around with these measurement cards, tag cards, Nappa cards, and struggling with getting GPS clock signals down into the server rooms. So finally we gave up, and we realized that the NTP synchronized clocks, they are fairly good. You could turn up the NTP update frequency a little bit extra, and then you get a fairly stable situation. especially during a shorter time frame. So if you just look at a window there of 2000 packets, the clock is fairly stable, and then you can look at the differences, so differential information inside the time frame. So the absolute end-to-end delay, we don't really log or care too much. It's more changes in the end-to-end delay. All right, so well, I can sort of recap on the queue stuff first, perhaps, which was what I said there. We have the minimum delay from the window, and then we look at the difference between the delay measured and this minimum delay, and try to log this. And this is actually the most interesting delay-based measurements we do. And we see spikes, and we see that there are queue buildups occasionally, as illustrated in this, the diagram, the lower one here. You can see that it sort of rises from hardly nothing and no differential delay, so you're sort of on the minimum all the time, and suddenly you can have several hundred milliseconds of delay without loss. Jitter is also calculated, but using this RTCP definition of jitter we found in our RFC here, 3550, but they turn out to not really be that interesting. They only show minor variations typically, or a few milliseconds, so not much to learn from that so far, at least. But then we have the trace route analysis we're doing. We have one part of it just simply looking for failed routes, so those stars showing up in the trace routes. Whenever a trace route never reaches its intended destination, we count those. And we also extract these ICMP errors reported by a trace route sometimes, especially the network unreachable ones. And then we also analyze trace routes to look for route changes. That's kind of a challenging exercise because you have load balancing going on out there, and especially towards the data centers, it's really crazy what you see with the trace route, especially if you're running traditional trace route, TCP trace route, and probably Paris trace route, which we should run but don't run yet, are likely to be more stable. So we've cooked up some way of learning what's normal of changes, and then trying to detect only the changes which are significant. And we ended up using cross entropy and sort of distributions, so logging distributions of IP addresses seen at each hop, and then using cross entropy to compare what's sort of the normal distribution you expect to see of these IPs with the one you just saw with the latest trace route. And we get some values there, and we look at sort of the difference, how these values changes, and it seems to output actually quite accurately when interesting route changes happen. And then finally, the last thing we've added to the system is these correlated events. So we first now started to look at the gaps we detect and also match them with the route change events we see. So if we see a gap first and then a route change event closely after, so 1 minute maximum after, we consider that they might be correlated, and that we report those as a correlated event. And we try also to identify the responsible router for that route change by and sort of look up ASN numbers for those. So as sort of an example here at the bottom here, we have a couple of events here in the afternoon where you have a gap and a route change, and then another gap after one another, and there was a 5-second downtime in this case here. And it turns out to be a router in ASN 224, which is Uninet or Sikt, our. So this is a router in our network doing something not fast enough. So it's useful, I would say. All right, that's pretty much the details I wanted to go through. You can join in. This is a project open for new contributors, and even though we will be working on merging the code and the system into the perfSONAR suite, I expect the current one to be running for quite some time while we're doing that work. And to join, you could either just look into this webpage, the Microdep Unit webpage, and study what's going on there, and use it for your well. If you see something there of interest, you could use the information and perhaps optimize some of your authors if they appear there. Or you can also add a node to the topology. Might be. If you're really interested, that's probably a good idea, so that you ensure that you measure something through your network. And that's essentially, as I mentioned earlier here, you can just set up a VM. It doesn't have to be a physical machine. VM or even a container should be enough, because these nodes are rather lightweight. 100 packets per second today is not very much. And sort of and the 1 minute trace route is also and the analytic part is not really very heavy either. So lightweight.
So we
container.
had one question come in that's related to this.
Right.
You said that you are going to be integrating this with perfSONAR in the future, but right now, could Microdep and perfSONAR run on the same bare metal server, or do they need to be segregated off on different containers or VMs?
I think they can run next to each other, because this is simply a package, Debian package, as you see below here, and it's lightweight, so you can install it next to perfSONAR. I haven't tested it, but I'm pretty sure it doesn't conflict with perfSONAR. The port ranges, I don't know. Maybe there's a conflict there, but that's possible to configure, definitely. So you can definitely.
Well, we're in luck.
reuse.
We do have a perfSONAR developer on, so I'll put
Right,
you
we
you
have.
on the spot, Mark, if you want to answer about that.
I don't know
Mark,
anything about
okay.
perfSONAR. I have no idea what you're talking about. Yeah, I don't think that should be. I don't think there should be any conflicts there. I think, and Otto, I think we talked about this a little bit
Yep.
a couple months ago, but you know, I mean, most of just about everything inside of perfSONAR, you know, puts itself kind of further down in the tree of the web server, and presumably, if your stuff does that as well, then there shouldn't be any. I don't see any reason that you shouldn't be able to run the same stuff there. Of course, the proof would always be in the pudding, and it's always worth trying it.
Yep. Yeah. And I guess what you probably would get of, call it conflict, is this system, the Microdep system, measuring glitches when you run iPerf measurements using your perfSONAR node, because then I guess you might fill up the link, and there might be some packet drops due to that.
Yeah, that is one of the hazards. But fortunately, you'd at least have the data that says, "Oh yeah, I was running that
Sure, yeah.
throughput
So,
at that point too."
Could be a periodic event, you know, a gap you see there, which is coincides with your performance measurements.
And we had one follow-up question here, is another perfSONAR related question. Is there a timeline that you're thinking about for integrating with perfSONAR?
Oh, well, we seem to get going now, actually. We are, as we speak, discussing with the Gia to get some decent number of hours to work for them on this. So by the end of the year, I hope we've gotten quite far, probably not done all. So in a year, perhaps, we should be quite far.
Okay.
Close to something stable, I hope. Yes. I have time for a little bit of a demo, have I?
Oh yeah, absolutely.
Let's see here now if I can web browser there. Okay. This one. Share. Here we are. All right. So hopefully you see this map here now. So essentially, if you go to this website, you get the global view as your first map view here of yesterday's datasets. So 23rd of June, and we show the gaps we've observed yesterday in sort of calculating them as an availability. That's sort of the default setting here now. So, and we have a color bar down here trying to sort of indicate the severe ones and the medium and sort of not that severe ones. And well, we can click on one of these then. Here we have one red one here going between Trondheim and Adelaide, where we have overall unavailability of 8,000 parts per million. And well, for those who are not familiar with parts per million, I guess 10 parts per million is 5 nines. So if you are at that level or below, you are 5 nines or better when with respect to unavailability and downtimes. So 8,000 is definitely not 5 nines. So this link has been struggling quite a bit during yesterday. And as you see here, the list of events, we have some quite significant gaps here. 40 seconds, 30, so half a minute, and more than half a minute gaps around 6 o'clock. There's obviously something going on, some flapping or whatever going on in the afternoon there, European time. Right, and well, as I told you, we have the big gaps, right? 27 of those selected, and we have all the small gaps which we don't really present in the list below, 137 there. And we also sort of give you an average time there of those gaps. Or is it the total time? Can't remember. This is there's a help text missing here. I should add that. Okay. We can look at well, we have these other views. You can have a quick look at that if you want to look at see if there's one node which is struggling more than others, for instance. If you look at the heat map here we are. The heat map for yesterday, and we do have a red line here as well, vertical this time, and it seems that the Sao Paulo measurement point has some issues, and we know about that. It's a host there behind a little bit of firewalls, and there's something a little bit complicated there. But still, we have the link we looked at is also red here, so worth studying. Okay, you could also see this information as a sort of summary table if you would like to sort or figure out how many nodes are 5 nines, for instance. If we then sort on availability, you could sort the other way perhaps. If we, okay, opposites. You see that quite a few have a very good unavailability, so they have 0 all the way here. So well, how many was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20, 30, 40. So we have 40, 50. Yeah, we have quite a few connections with very good availability. These are essentially the same numbers you see in the pop-up windows in the map, but you get them sort of in a table. Okay, gaps. We also have queues. So you sort of see the same. Oh, we have a glitch. This is not quite right. It's not supposed to be like this. All right. Okay, for some reason there's queues are not coming out quite right here. But you could also actually, while studying the gaps on the main page here, you can change the variable you study from unavailability to, for instance, the big gaps, the small gaps. But you also actually have queues here, and this tends to work a little bit better. Okay, now there's something. We have a glitch with the queues today. All right, but let's have a look at perhaps the most interesting data set we have recently added, these correlations, and see if we can find some route changes which has actually caused a gap. And I know there was one I saw, was it the 8th of June? Here we have one which goes from Zurich to Auckland, so seemingly eastbound, but well, as you know, that most of the traffic going from Europe to Oceania or Australia and Auckland quite often goes through the US. And if we click on this one, we see that we have a gap of 8 seconds taking place 6 o'clock in the morning in Europe time. And well, we're struggling a little bit with figuring out the ASN of this IP address, but we can actually take a look at the routes here. Here we see what happened during that day, and if we zoom in a little bit, we see here that the darker blue colored blobs here show the most common path going from Europe to Auckland. You see the lighter colored ones is a path which happened just during a shorter time period. And if we hover on one of these, and then I move down to the list here, we see we get this entry, and 6:45, this is when this router first seen in the traceroute information. 6:45, that coincides very much with the event reported by the Microdep system there. So definitely one of the Internet 2 routers here suddenly appeared due to a route change. So then we essentially know that we look here and perhaps it would be an idea to look into the configuration of this Internet 2 router to see if something could be improved, because it did change the route, but not perhaps as fast as you would like it to do. All right, I think I'll actually round off there. I could of course go on and click around in this tool for a long time, but I think I've showed you most of the good stuff now. Is there any more questions at this point?
So far, no other questions, but certainly, since this is a small enough audience, I think what I may do is just, if anybody does have questions, I gotta find the setting. If anybody does have questions, you can just sort of unmute yourself and ask. I think that this is a really cool tool, so I'll just sort of put it out there. For those of you that represent either campuses or regional networks, you know who you are. Is anybody interested in maybe test driving this and seeing what it may do? Or for those of you that are participating in the routing working group with GNA, is this something that you would want to maybe discuss with the members of that working group?
Because what I perhaps didn't show is that you can have a sort of a setup for your own network then, which we have in Norway. We have a sort of an own measurement network, just focusing on the national backbone.
Go ahead, Jorge.
Jason, I don't know. This is a little bit related, unrelated. I don't know, but want to ask: is there data available, for example, for some researchers? The data that you see through this network might be quite interesting. So, is there a chance that you can share the data, the traffic data?
No problem, because there's no privacy questions in this case, because there's only probe traffic generated by us forwarding to the network, so no private IP addresses, nothing like that. So the datasets can freely be studied by researchers. No problem.
All right,
So
and we can just email you to.
Yeah. I think we have all these events then, which we have extracted from the probe traffic, but so far we actually also stored the probe traffic, all the measurements done, you know, all the logs from these the traffic sinks we have, so that they are on disk, and we have, you know, a cluster packed with those data sets. So please, if you think you can study those and do some good research on them, we can definitely give you a copy of those.
Thank you.
All right. Anybody else have anything that they'd like to comment on or talk about?
So the contact point is essentially, for the tool at least, or for me too, is essentially the name Microdep at sikt.no. So I can put it in the chat perhaps.
Oh yeah, put it in the chat, and I'll make sure I also put it in the email that I send out with the video link.
Yep.
All right. Well, I think that's it for comments. Up, but and there's the email. So thanks everybody for attending. We are going to be on a couple-week pause because it's summer. So our next talk won't be until July 22nd, so about a month from now. And we'll have Ed Cologne and the always entertaining University of Michigan interns talking about more perfSONAR, Wi-Fi monitoring with PSSID. So I will send out a reminder when we get closer to that. But otherwise, hope everybody has a good first part of your summertime. If you're going on vacation, certainly enjoy that, and we will talk to everybody in a couple of weeks. Thank you again, Otto.
Thanks, Jason, for letting me join you.
Thanks all. Bye.
Bye-bye.